So hello, everybody. Welcome to today's session around leveraging AI or artificial intelligence infused value stream management or VSM to stay relevant. My name is Don Jackson. I'm a chief technologist here at Micro Focus. And with me today, I have Chris Trimper, enterprise QA automation architect from Independent Health. Chris, say hello.
Hello, everybody.
So we're going to just jump right into this. Like Jennifer said, if you've got questions, you can feel free to pop them into chat and we'll go over them. If it's appropriate to be included in the recording, then one of the administrators will interrupt and ask the question. So as Satya Nadella, CEO of Microsoft, famously said, every company is now a software company. And this means that if your software falls behind, so do you. And this is why everyone is digitizing these days. Some of the reasons are obvious, frankly. Everyone else is doing it, so you don't want to be left behind. Your customers are demanding it. They need more convenient ways to access services. And your own research indicates that your projected earnings will increase with a digital presence or a better digital presence than you have today. Now, I recently attended an in-person event. It was the first one that I've been to since COVID-19 struck. And after 2 years of not going anywhere, it's great to see people in person. I hope you get the opportunity to attend some in-person events as well. But because of that and that sequestering and that at-home environment, there's been an even stronger drive to digital and online applications. Stores that had only physical presence before, and even restaurants that only offered eat-in dining, have moved to online presences to allow customers to order remotely and or have it delivered to their home. So it's not enough to simply tick the quote-unquote digital presence box, though. The customer experience has to be smooth. It has to meet performance expectations, and it has to work on any device that the customer wants to use. Now, automation underpins this digital transformation, especially around testing and quality. With the speed of updates to the software, the exponential rise in the number of combinations of the different platforms and the different scenarios that need to be tested, automation testing is essential for organizations to be able to get a continuous view of application quality. But frankly, there isn't a gas pedal that you can just push down to speed up application delivery. And there isn't a dial that you can turn to increase test automation. But why not? So firstly, complex enterprise applications have a lot more moving parts and components. Some of them are owned by other parts of the organization. So synchronizing across the different components and teams, all of which have their own goals, is not easy because teams are not always keen on collaborating as much as they should. So there isn't enough coverage. And even if there was, we wouldn't know about it because of the silos and the communication challenges. Then there's also so many technologies and environments and devices to test. There's an endless combination and configuration of these, and it's not easy to find tools that can cope with all of the different possibilities. Now, automation underpins continuous delivery and continuous deployment. And the speed that we can deliver and deploy is related to our ability to automate tasks and tests across the entire software delivery cycle. And then there are the details of covering all of the data combinations and analyzing why tests fail and fixing the problem, which can, of course, be with the application itself, or maybe it's just a problem with the test. And then there's the maintaining the tests and the application continuously evolving. And this is, frankly, it's just never ending. So a few months ago in December of 2021, we at Micro Focus commissioned Forrester Consulting to take a look at the state of software testing and quality management practices at enterprise in the financial services, healthcare, and retail sectors. The result of that commissioning is a paper called Boost a Testing Effectiveness with AI-Infused Tools and Quality Management Practices. And it's based on an online survey of about 316 software testing technology decision makers across North America and the UK. And it contained a mix of 226 decision makers whose organizations only use traditional automated testing and or manual testing, and about 90 decision makers whose organizations already were using AI-infused testing. Now, one of the questions was about how happy they were with their traditional testing tools and practices. And it turns out the answer was not very happy. Only the processes, as you can see on the screen, scored over 50% happy, but less than 50% happy about the speed of testing, and under 40% are happy with the amount of test automation that they're doing or the amount of effort to maintain tests. And then it gets even worse. We get down to like the 35% mark, or almost 2/3 that are just not happy with the visibility of their tests and their test results and their quality status. And then even fewer are satisfied with the reusability of their test assets or the tools that they're using for test management and test execution. So clearly, the message is most people are not happy with their testing tools and practices. But what are they measuring that against? Let's see what they're trying to do with their testing. Most of the respondents who use traditional test automation or manual testing want to become more effective so that they have higher quality in production. And half of them are struggling with budgets and finding trained QA engineers. So they need to do more with less and reduce testing costs overall. They also want to increase the amount of automated tests and reduce the amount of manual tests. Now, I'm not going to go through all the lines here, but I think you'll probably identify with most of these, if not all. So 46% though say that they want to test smarter. So let's kind of drill into what does that mean. So that study found that testers using traditional methods of testing needed help with first identifying what to test. Testers waste a lot of valuable time figuring out what to test and testing the wrong things. More than 3/4 or 77% of the respondents said that they waste time testing functionality that the users don't use much in production. And almost the same number at 73% said that they have redundant test cases that are hard to maintain. Testers need help sifting through the noise and should be able to prioritize their testing. Nearly 60% of respondents agreed that their organizations want to identify and optimize what they should or should not test when a software change happens, especially when software changes are constrained by budget, time, and resources. Conducting the right testing will go a long way in preserving valuable resources. It'll boost employee confidence and morale, and it frees up bandwidth for more creative testing. The second big point here is managing growing complexity, scale, and continuous integration pipelines. Testers continue to struggle to keep up with software changes because their testing isn't automated enough and they don't have the right testing assets. 75% of the respondents struggle to stabilize their CI or continuous integration automation pipelines and quickly differentiate between failures and false failures. Continuous integration could help resolve issues before developers delve further into the development cycle, but that's only effective when the tests are automated. Unfortunately, 54% of the respondents felt stuck at current levels of test automation and are struggling to improve, finding it hard to write and maintain automation scripts. And 69% struggle with test data management and want to create synthetic data quickly and easily, while they also meet GDPR or General Data Protection Regulation and comply with other regulations. When testers have scripts available and can reuse test data, they can be more proactive and effective and quickly test to identify issues. The third big bullet point here is about optimizing testing strategy and risk. Testers need help improving their testing strategy and need more testing intelligence based on analytics and better test management. 75% of decision makers want to optimize their testing strategy to maximize business coverage and reduce risk, while 74% want to maximize technical coverage and reduce technical risk. Now, rather than rely on intuition, 73% of respondents agree that they want to bring more analytics-based insights into their risk-based testing approaches. Now, because of time constraints, testers need to prioritize testing activity on what matters most to the business. And because nobody can afford 100% test coverage, They want to make sure they can focus on the highest business and technical risk areas. So it comes down to, frankly, better test design, better test automation, and better test maintenance. So now that we understand what's holding us back and we can agree that we need to be smarter, here's what testers need to get to the other side. First, testers should be able to share their testing assets across different tests and different scenarios. Reusing scripts is key to reducing maintenance costs. But I'm not only talking about sharing assets within the functional test effort between the developers and the automation engineers. You can reuse tests that you've created for your performance tests so that you can create the most accurate performance tests based on actual usage scenarios. And to get a comprehensive picture of the status of your application's quality, your testing tools must integrate with other tools that you have in your DevOps ecosystem. Now, everyone should be taking part in the automation effort. Developers and more technical testers can start testing earlier in the development cycle, often referred to as shifting left. In fact, we'll see this soon, you can even start testing at the mock-up stage, even before code has been written. And similarly, less technical people should be part of the testing and even test automation. By bringing people who understand the business and how the application under test is used in production into the testing activities, we can ensure that the testing, and we're testing the right things, the right flows. That means we need to lower the technical barriers and make testing and test automation more accessible to everyone on the team. And when you have to test on mobile devices, there's always the issue of not having enough devices or not having them available when you need them. By centralizing your devices and providing easy access to them remotely, testers and developers can get the devices that they need when they need them. And when one tester isn't using a device, another one can use it. That way you maximize your return while reducing your investment in owning and maintaining all these physical devices. And last, and maybe the most important one, artificial intelligence brings opportunities that have never been possible before. With advanced techniques such as machine learning, computer vision, and natural language processing, AI takes a lot of the work out of the tester's hands and leaves them free to focus on the test's flow and the other things that really matter. But before we go down the rabbit hole too far, we need to first talk about value stream management. Forward-thinking companies are looking to leverage a revolutionary but pragmatic approach called value stream management. Value stream management's roots come from the manufacturing space and are innovatively being now applied to software development and delivery. Value stream management, frankly, is a game changer. It enables organizations to track, analyze, and predict resourcing, risk, waste, value delivery, and it does all of that as the product flows all the way from strategy to delivery. And that all leads to superior business outcomes. The software development market has been defined by key strategic inflection points, and we're upon one of those today. This shift is being driven by a proven approach that we call value stream management. This market is starting to attract the attention and interest of companies large and small, and is forecasted to exceed over $1 billion in just a few years. There is no dominant market leader today. The opportunity is out there for all of us to seize. Today, most companies, they use a modern, agile, and DevOps approaches to software development. For most, there's this pragmatic assumption that things will work as planned. For example, that the strategies will be clear, that the features will be optimally prioritized, that you'll have adequate quality and adequate testing, you'll be able to attain that. And overall, the product that's brought to market will be on target and on budget. Now, most companies employ a range of different tools from a diverse set of vendors and open source to support their software development lifecycle. And if they were to map out their value stream, it might look something like this, where they've got the correct strategy, the right features, they manage risk, they've got no rework or redesign, and they end up with happy customers. The problem is that the reality of what we see today looks more something like this. So in spite of all of that investment and the experience, the reality is that software development's a complex business. Many different factors impact the art and science of software development. And those factors might include things like the changing market conditions and the priorities by the business, inadequate testing, a lack of automation. You could have under-resourced groups, and you could have delays in completing products on time, and the budgets get exceeded. And then you end up with significant redesign and rework, which all of these things lead to the quality being below your targeted standards. And that leads to your value that you create is not optimal. It's not what you expected. Now, to address these points of friction, a new thinking and a new approach is warranted, and that's called value stream management. So in value stream management, what may happen is it'll highlight and give you insights to say, I need to focus on this area because of what I'm seeing. So value stream management, it works by holistically analyzing the software development lifecycle from strategy all the way to delivery. It invokes a new set of value stream metrics that include things like software development lifecycle efficiency, cycle time, throughput, quality, costs, efficiency, risk exposure, and more KPIs that we're not going to go into today. And it does this by integrating with your existing tool chain and related systems of records. So what ends up happening is because we gave you the insight to know to focus on this area, you can transform this and your key indicators that you see on the right here into looking something more like this, where your key performance indicators are showing either green or trending towards green. The result is a positive impact across the entire software development lifecycle. When done correctly, value stream management helps ensure that your organization adopts the right strategies, prioritizes the right features, makes the optimal use of your limited resources. It maximizes the use of automation where appropriate. And all of that leads to eliminating rework and unnecessary handoffs, which delivers superior products. Those superior products lead to higher levels of customer satisfaction. And that higher level of customer satisfaction leads to superior business outcomes on a regular basis. This VSM has the potential to be a real game changer for companies both large and small. Now, with that higher level of understanding of value stream management in mind, now let's shift gears and talk a little bit about how AI can influence value stream management and the broader organization. In short, value stream management is really the future of software development and delivery. Some people call it the future of DevOps. It complements and integrates with your existing software development and delivery environment to empower you with the insight you need to predict, plan, analyze, and take action to maximize the delivery of value. The result is the ability to deliver superior software solutions for your customers faster, and competitive advantages is for you as an organization. You can adapt, though, VSM to your own unique environment and your own needs and take it at your own pace. Now, for some people, that means I'm going to focus on starting small, and I'm going to start maybe and expand over time, and I'm going to focus solely on functional testing and improving functional testing. For some, that means I'm going to do the entire value stream management, and I'm going to adopt it all the way from portfolio management through agile development, continuous quality, and operations. But I'm going to do it just on one product as a pilot product first, or a pilot solution or a pilot application. Whatever the case is, the old adage of how do you eat an elephant? You eat it one bite at a time, right? That adage of starting small and showing results works here. So let's take a look at where AI can be applied in the landscape. So you've probably, if you're attending this, you've probably heard us at Micro Focus talk a lot about functional testing and AI in functional testing, where computer vision and natural language processing paired up with machine learning makes tests more robust and easier to maintain. But in performance engineering, you can have AI be used to figure out what scenarios users frequently use and create realistic performance tests. It can detect anomalies analyze performance test results, and even sometimes suggest adjustments to the application under test to improve performance. In security testing, AI can be harnessed in penetration testing to find vulnerabilities more quickly by figuring out which systems should be tested and determining the best paths to take through the application to highlight weaknesses. For agile planning, AI can be used to assess risk and estimate effort. In quality management, AI can determine which tests to run, the impact of a test. It can identify flaky tests that fail appearingly at random, or oscillating tests that flip between pass and fail, and how to optimize the tests and increase test coverage. AI in DevOps can help figure out what's happened in a build, or why it may have failed and who should fix it, or sometimes even self-heal. It can make recommendations about what lab machines are best suited by running tests and how to parallelize them and parallelize that test execution so that you can get results as quickly as possible within the constraints of your resources that you have available. And looking more broadly, AI can help project and portfolio management teams make decisions across a wider organization. And that can take into account things like different individual teams and their needs and their products, individual products, the budgets, and the resources. And of course, once we've released a product into production, AI can help customers manage support tickets. It can improve the service reliability. It can analyze log files. It can bring production data back into testing and monitor the system to identify abnormal or even sometimes suspicious activities from a security perspective. And it can protect systems from threats. So together, all of this provides inputs into the entire value stream delivery process with the potential to surface insights that the team can then use to take decisive action. So we at Micro Focus have introduced our ValueEdge value stream management platform. It's a flexible, cloud-based solution that's delivered fully managed services for any organization. This modular platform design gives you flexibility to start with as many services as you'd like. You can tailor ValueEdge to best suit your organization's tool chain, and its intuitive user interface and unified user interface and pre-built connectors make deployment and value generation quick and easy. Our ValueEdge architecture is where it all starts. We've designed it from the ground up as a seamless cloud-based platform powered by an advanced data lake, a common data model, a robust integration hub with a sophisticated AI engine that includes a framework for metrics, advanced analytics, and machine learning capabilities. The result of which is a service solution that easily integrates with your existing tool chain from today. Now let's drill down into one area. So we talked about you could start in one area. Let's drill down into functional testing and talk about AI and functional testing. So AI is a huge topic, and I'm not going to do a primer on the entire field of AI, but we need to understand a couple of high-level topics. First, machine learning is about developing algorithms that improve based on experience and data. In the case of computer vision for functional testing, it's about understanding what objects are on a screen. Machine learning algorithms are fed many, many data points that consist of objects and some kind of tag that describes what the object is. The goal of that is to train the algorithm to understand what an unseen object would be based on the prior experience. Now, this type of machine learning is called supervised, where the training data is marked with the expected result. And the goal is for the computer to figure out a way to get the expected result when it's presented with a new sample. Now, unsupervised machine learning is where the algorithm isn't given much initial information about the data. And the purpose is to find patterns in the data. So an example might be segmenting your customers based on marketing data or visualization data. And at the heart of this model is a collection of nodes that are similar to a biological brain's neurons. These artificial neurons process data and pass it on to other neurons that process the output further. The way that the artificial neurons process data is by applying some value to the data. The combination of these values defines the output of the algorithm. The learning algorithm then reassesses how far away the output is from the expected result. And then by adjusting those values or the weights, as the algorithm is exposed to more training data, the combination of those weights should eventually converge on the desired result. Deep learning algorithms consist of many layers of these artificial neurons, which emulate the way a biological brain works and is prevalent in applications such as computer vision. Now, AI can be used for a multitude of applications, ranging from relatively simple to extremely complex. In the case of computer vision, we take labeled training data, such as the profile icon or the shopping cart. In this example, we have 4 different representations of each, but they all represent the same thing. By running each example through our layers of algorithms, we can see whether we can identify the object correctly. Each time we run the test data through the algorithm, we tweak the weights and try to get closer to the correct identification. And each prediction is assigned a score, and if the score is sufficiently high, it's considered a match. Now, one of the main advantages of this type of pattern matching is that it's not performed on the pixel level. Now, yes, the images are analyzed based on their pixels, but it's not the pixels themselves that are important. What is important is the patterns that are represented by the pixels. So as long as the algorithm can figure out the various features on an image, it's able to determine up to a degree of certainty what the image represents, regardless of whether the image is a low or high resolution. So once we've tuned our algorithm based on the expected data, we then release that tuned algorithm or the data model, and we expose it then to live systems, which our customers end up doing. When the algorithm encounters a new data point that it hasn't seen before, it can assign a score based on how high the score is, we can state what that object is. So you see here, we've got this new data point that's that you and I are saying it's a shopping cart icon, obviously. And the model can go out and go, yep, that's a shopping cart, I agree. But AI is all around us. It's used in medical applications, such as analyzing scans and providing a backup to doctors. It's fundamental to self-driving cars by recognizing street signs and pedestrians and other objects in the environment and make intelligent decisions about how to proceed or whether to slam on the brakes so it doesn't plow through a pedestrian. And we see it when we try to access customer services or support, where we often greeted by a bot that can answer many of our questions. And if the bot realizes it can't solve our problem, it's sensible enough to hand us off to a human operator. Frankly, I've been dealing a lot with these bots lately with some personal stuff with an estate I've been trying to settle. So I've been talking to a lot of customer support bots. I'm not a huge fan, but frankly, they are getting better. And they're reducing the number of interactions with real human operators. AI, though, like I said before, is a vast field. And we can break it down into major areas of research into these topics. Now, each of these is a field in itself, right? It's a vast field, and it's way beyond the scope of what we're talking about today to dive into each of these. But for AI and test automation, we're largely focused on these 3 areas: computer vision, which we've just talked about to identify objects on the screen; machine learning, where we can use supervised learning algorithms to classify the elements we found on the screen and understand what to do with them; and natural language understanding or natural language processing to help design test cases. Now, the other disciplines are still there, but I kind of grade them out because I didn't want to remove them completely because many of them are still relevant to testing, but our focus in the moment is on test automation. And we've talked about some of the other applications of AI in testing earlier. So let's see how AI is applied in functional testing in practice. The best way to illustrate this is to see it in action. A few years ago, we began our AI journey with our flagship test automation product called UFT-1, which probably most of you are familiar with. You may know it as UFT or even QuickTest or QTP or QuickTest Pro. It's evolved and it's improved over the years and has seen a few name changes. By using computer vision to identify the different elements on the screen the same way a human does, without needing to understand the underlying implementation of the user interface or its technology, which is how most tools currently approach object identification. And then we have a neural network that's kind of like the brain that will understand the element and decide how to interact with it and manipulate it. And then we've also embedded natural language processing capabilities. So tests can be written in a very simple way, looking very much like plain English. Now, we've also added these AI capabilities to UFT Developer, and UFT Developer delivers test automation capabilities within a developer or dev tester's IDE or integrated development environments, things like Eclipse or Visual Studio or IntelliJ. So let's see it in action in UFT1. So this is a short demo. I'm not going to show off our products. I'm just trying to show you how to use an AI analysis to understand the objects on a screenshot without knowing anything about the application under test. This is the strength of AI-based stuff. So at the moment, you can see we do AI on web and mobile applications. We're working to get it to work on desktop applications, but right now it's web and mobile. We can select a folder that contains screenshots or mockups. And as soon as the image is loaded, the AI algorithm scans it and identifies objects it can recognize. And you can see them highlighted in purple. The way that it works with mockups is identical to the way it works on the live application. The only difference is that if you're working against a live application, you can actually drive the application directly from the screen as well. With the mockup, there's no live application. In this example, we have 3 screenshots to work with, and we can flip in between them. We actually recognize objects and text. So what you'll see in a second here is you can turn each of those on and off. So right now it's recognizing the second screenshot that we have, and we can flip back to the first screenshot of the mockups. And now you can see you can do text as well. So you can identify the text elements. We also, so like you can see here the profile icon. The system recognizes it, and there's a number of potential actions that you can be done with it. And it provides a dialog box where we can configure what we want to do with it. And if there are a number of similar objects on the page, we can actually specify which one we want by assigning its position or its relationship to other objects on the page. Once we're happy with our selection, we can add the object to the test. In this case, it's a simple click of a profile button. But the key here is that everything needed to click that profile button is contained in this one line that you see on the screen. There's no reference to an object repository that needs to be maintained each time something changes in the UI. With AI, if something changes in the UI, the AI algorithm should be able to recognize the object and the test can just continue to work. So it's not self-healing, it's just not breaking. And it lets you focus on the logic of the test. So the key benefits of AI technology are that it's quicker to design a test because we don't need to know anything about the application's implementation. We can get more coverage because we don't need to write separate tests for each different device or operating system that we need to test. Most of the UI is the same. We can just run an existing test on a new environment with little to no modification. And if the test passes, we've expanded the coverage and support for our application. And finally, there's a significant reduction in maintenance. That's because if an object on the screen changes in some way, but it's still recognizable, the AI will find the object and drive it. It's not going to fail the test for something innocuous that gets in the way of testing the logic and flow of the application. So Chris and I were talking about this previously, about he had a situation come up where he had a bunch of automated tests with AI and the developers came to him and said, "Hey, Chris, what'd they say to you?"
They were telling us that we had a change in framework to accommodate for new hooks into the application, the mobile application, and they were changing from framework A to framework B. So it'd be like switching from some non-Angular to an Angular thing on the web for anyone that's not in the mobile. So you can think about it as an absolute total rewrite of the application for all intents and purposes. So I looked at them and I said, well, we've kind of prepared ourselves for this. We're using this new technology. We're using computer vision to interact with the screens, to interact with what's on the physical screen of the device. So I asked them, I said, is the user experience going to change? And they said, no, it's not supposed to. It's just a framework swap out. So, all right, do it, and we'll be fine. And it was the first time we had something like this, so I was kind of boldly just saying, well, it should work just fine because I understand how it works and it should be fine. And we had far less than 10% maintenance change, and any of it was really around how from framework A to framework B, the user experience did have to change in those examples. But we were able to ensure the experience. We were able to ensure that the flow was the same from an end user, and we had, I can't say no maintenance cost, but nearly no maintenance cost from that.
And I'll
So
tell
we're
you
able
from
to keep our
experience,
coverage.
So I had a similar role to Chris prior to coming to Micro Focus, and I was a customer for 17 years. I actually had a similar situation happen where our e-commerce platform, we were changing the platform. We were on a really old technology and we were modernizing it, going to a new technology. The user flow didn't change. The labeling on the objects didn't change, but it was a completely new framework. And I had to throw out all of my automation and start all over from scratch.
Oh,
and when they came to me, we had one guy who threatened to quit. He's like, what do you mean that you just threw out all my work over the last 3 years? Are you kidding me? And so that experience that Chris just talked about is really important.
yeah, it is kind of crazy because I was standing there in the meeting. I'm like, I know how this thing works. I know what it's supposed to do. I'm a tiny bit nervous saying that it won't change anything and we'll be just fine and automation will persist. But I went with it anyways because, oh my God, I knew from the past. So we've been using the computer vision AI enabled engine for going on 2 years now in some capacity. So we knew what it could do and we had utmost faith in it, and we were able to actually prove that it didn't make a difference. In interface, I shouldn't say it like this, it's not quite that, but interface is an interface. The experience that the person has rendered on the screen, which is just mind-boggling if you think about any traditional automation. Let's talk about the rendering and not utter the dreadful word bitmap, which we don't ever use or touch. It's insane in a crazy way. It's hard not to get excited talking about this, but I want to let you continue what we're doing for sure.
So let's talk about lowering that testing barrier. So being able to, how can we leverage AI to make it so that we can get more of the non-technical folk involved? Because Chris and I are pretty technical guys, but we want to be able to get people who know the business involved.
Oh, it's huge. We just had a discussion the other day where we were talking about how an automation tester doesn't necessitate a good tester. And it's really hard to embrace what our business testers, our SMEs, our application SMEs, and however you call them in your industry. It's really hard to take what they have and embrace it in those doing automation. Just in the same way with traditional automation, it's hard to take all the automation know-how and put it in their heads. So they're always kind of like battling against each other to try to represent it well.
Yep. So in a manual tester world, you might have screenshots or the application looks like this, and these are the steps that you get. Click the profile, click search, type 17T into search, right? What traditional test automation looks like is it looks like it has to interface with the application using the document object model, the DOM, and the locators in there, and it uses this text in the bottom. So why can't we have tests that look more like what you see on the left-hand side and the top on the right side? Well, what we're looking at now is actually very similar to a manual test. This is our AI codeless test solution. Each line can be read and carried out by a human, because you could click, as long as you know what a hamburger menu is, which is this thing over here. That's what it's called. It's called a hamburger menu. For those of you who don't do any mobile work, click the profile, type in the value into that username input. You guys can all do that. A system like this enables non-technical testers, or at least less technical testers, to automate websites and mobile applications. They don't need to know anything about the implementation of the application under test or about coding. So let's kind of show how this would work. So this time, we're going to write a test for a mobile device. We're going to use a really old iPhone 6. And let's choose our shopping application and our shopping app and packaged version of the app to test. Now we can actually launch the app on our iPhone, and we get a representation of the iPhone in the window to the right of the screen. Once the app is running, we can start to identify objects within it using this identification center, this object identification center. And it says things like it's a hamburger menu or a shopping cart. And we can say, click the hamburger menu. And you can see here, I told it to click the hamburger menu and it did. Or I could just type it in near plain English. If I type it correctly, and I can type, click the profile, and it'll click the profile. And you can see I'm refreshing on the screen here, and I'm saying, okay, now I want to click on that, and I want to have it input text into that field. So I can do the username and the password and enter that in there. You also have the ability to data drive those from a data sheet inside of model-based testing. Or you can see here, maybe I want to do it by, I know what class the object is. So I'm a more technical guy, and I want to specify it. Or maybe I need to say, hey, I need to find the first one from the top. I need to find the first button from the top. So you can actually walk through it and have it re-identify what's going on there. And you can see that it's near plain English that you see on the side. You can also have it highlight things in the application to say, hey, go find it. And if the AI engine isn't able to find it, you can actually go back and identify it by its object properties as well. So you're not reliant on what if you have some unique object that you need to click on that isn't recognized by the AI engine? Well, you could provide feedback by clicking on this help us improve, so that we can add that into the training data that we talked about earlier. So here's an example where this details isn't recognized by our AI engine. We purposely made it not work. So now I can actually use that and fall back onto that properties based if I wanted to. So the whole idea here, though, is that this script is in near plain English. And here is showing that feedback mechanism that we talked about, where I want to say, hey, I want to have this recognized as a details icon and that you can click on. You can send that feedback. So that'll get added, can get added into the training data that we use to train the model before we compile it and send it out as part of the product. So now that we understand codeless testing, we can harness its capabilities to automate flows through the application. By building a model of the application based on the various screens and potential user journeys of the navigation, we can gain significant test automation coverage without having to code. So model-based testing puts the business user at the center of testing activities, and they can work together with test automation engineers. So it gives you better collaboration. It's a shift-right management and governance layer for functional testing. It helps align functional testing activities with business requirements so that you can work smarter. And it's centered around easy to understand graphical model at the application's business processes. It employs smart coverage strategies for optimal test design. And it relates models and tests to agile work items such as features and defects. And when the automation can get done using that AI codeless tool that I just showed you. So I always find it that a picture helps us understand concepts. The old adage of a picture paints 1,000 words. So I thought it'd be helpful to lay out how model-based testing solution would work from the abstract all the way down to the specific. So first you start in the design realm. So you should be leveraging any BPMN or business process modeling notation process models that you already have in place, plus any existing automated tests that you have in place to give you a head start to build your model and component or unit library. The BPMN models should be imported and reused to build out the process models. Then you can overlay the nodes in the model with the automation assets that you've imported as well. And now, once you've done that, the user can review each model and underpin each node with the appropriate implementation artifacts, so their appropriate automated unit. Now, once you have the model ready, then you can transition to the path analysis, where each path or flow through the model is laid out for the user based on the coverage strategy that you've specified for that model. And that coverage strategy can be driven by your current needs. So for example, maybe you have a change that's occurred and it's a production down event. So you need to do the quickest possible test you can and make sure that you hit every node. You don't have time to test an exhaustive test where you test every single branch, but you need to make sure every node is tested in your model. That's an example of a coverage strategy. So once you've chosen which paths that you want to cover for your model, then you can go to the point of creating the test. And once you start the test creation process, you're then transitioning into the execution realm. The solution then creates all of the tests that will be available for execution that represent the paths or flows you've selected. Those tests are then injected with test data, which could be getting fed from your test data management solution, and you're ready for execution by your CI or continuous integration tool. The CI tool then executes the test and provides results back to the tests, which then in turn provide coverage information through to the backlog item covered through the model. Well, now when a change occurs that changes a model, you start the process over again and you analyze the paths using the appropriate coverage strategies, you generate new tests and you execute those tests. Now, this is a little bit different than how people currently usually think about testing. The tests themselves now are disposable assets when you do model-based testing. It's the model that's really the key asset here. And this is a radical change for testers or test engineers frequently. So here's a video on utilizing coverage strategies. So this is a really simple model I created for our demo application that's called Advantage Online Shopping, or AOS. Essentially, you can do a product search when you're not logged in, choose then to log in or stop. Once you've logged in, you can clear the cart, search for a product, add it to your cart, or abandon your cart and log off, or add it to your cart and check out and then log off. Now, this is a very simple representation of an e-commerce model. So now that we've got the model, we can set up our coverage strategy. First, let's look at full coverage strategy, where we want to make sure we hit every branch through every decision point. For this incredibly simple model, you can see that we have 5 possible paths through the model. Now, if we change the coverage strategy to be sanity test, now we only have to run through 2 paths to sufficiently test our model. Each node is hit, but not every branch of every decision point. Now, of course, you can modify the settings to customize that as well. So maybe you have a specific point that you need to test all of those branches because the change that's being made in the application was changing that decision point. So you need to make sure that you exhaustively test that decision point. Or maybe you have the complete opposite occurring, is that you're early on in the development of the application and a specific node doesn't exist yet in your application. So you need to avoid that node in your tests because the functionality is just not built yet. The whole point, though, is that you can focus your testing and streamline how to adequately test based on your current needs. So Chris and I have had an interesting conversation talking about this concept. And I mentioned that this was a simple e-commerce model. And the reason that I say it's an e-commerce model instead of a model specifically for our Advantage Online Shopping is because with the concept of the user experience and focusing on testing through the user experience, if I want to do a product search on a shopping application, I don't care if it's our AOS or maybe it's Amazon or maybe it's the Best Buy app. It doesn't matter to me because it should all be it should all recognize the objects the same way. And if you start thinking about what that could mean, if you have multiple login across all your applications, instead of having one login per application, now you could potentially have one login script that covers all of your applications. If you think about the concept of a login process, you have to get to the login page, which usually is clicking on a profile icon. You type in a username, you type in a password, and you click what's called the sign-in button or the login button. And with our analogous words engine that's inside of AI, it doesn't care if you call it sign space in, all caps sign in, lowercase, mixed case, it says log in or log space in, doesn't care. If you think about how you can abstract that out, now you are further reducing the number of tests that you have to write and maintain. Chris, did you want to add anything to that?
I think this is why when I'm talking about computer vision using the AI engine, I speak so heavily about user experience because it goes hand in hand. And actually, it's comical because the first time you and I had this conversation talking about just this, I laughed out loud, and you're like, "What are you talking? Why are you laughing? What's so funny? What did I say?" They said it's comical that I had something half right, and that it's meant to be about the experiences. The experience of logging in isn't different from application A, B, C, or D, unless it really is. The typical login experience is a username, a password, a login button, maybe a remember me, maybe not, but it doesn't deviate that far. Experiences, for the most part, don't deviate far. If I talked about, in healthcare, if I talked about searching for a member, I probably only need, across 10 applications, maybe 2 scripts using this kind of technique, because there's probably not more than 1 or 2 experiences required for that to occur. We almost, in our heads, need to start thinking differently and stop thinking about scripts and really start thinking about experiences. These bubbles here, I know what they are from an MBT standpoint, but I think of them as experiences. And when I think of them that way, it makes the world tangible. It makes this not scary. And frankly, I think it just demonstrates how MBT AI engines speak heavily to kind of going for the shift everywhere, and not shift everywhere from domain areas, but domain expertise and those personas that act in those areas of shifting.
Absolutely. So you might say, what's in it for me? So we've talked some about theory, we've talked about some in practice, but what does this really mean? So that same survey, it turns out that decision makers that use AI-infused testing were nearly twice as satisfied with testing as their organizations compared to their counterparts. And you can see on the screen here is the delta between people who, on the left-hand side, use AI-infused testing versus the people on the right-hand side who don't use AI-infused testing.
So I have a funny story about that, if I can, super quick.
Yeah.
I played a prank on one of our people. So in mobile, we use AI-infused testing for all of our mobile app testing. And I played a prank on one of them, and I said, we really need help on this other project. I want you to go to this other project. Admittedly, it's an area where currently we don't have the means to do AI-infused testing. And I'm going to wait because I don't want Don to spit his coffee out. But they pleaded with me, no, please don't send me there. I don't want to ever work on that project ever again. I'm like, why? They're like, because you made it easy, and now you're taking that away from me, and that's just rude. And then I kind of went, yeah, I gotcha. I said, really, I asked you these questions because if I asked you for feedback, you'd give me one sort of feedback expecting what I want to hear. If I threaten to take it away from you, all of a sudden it's like, no. And then I get the real truth of it all. And that was kind of cool because, again, it helped us realize the impact of the decisions that we made.
That's awesome. So speaking of impacts, it's almost like, we prepped ahead of time and talked about some of this stuff.
Comically, we didn't. We just winged it. This is winged, folks.
There are actually quantitative benefits as well. So when in that same survey, so talking about, what people who are using AI infused, these are quantitative metrics that they gave out there. I'm not going to go through all of them, but the clear message is that AI is having a positive impact. So how do I get there? If you're looking at to start leveraging AI, here's some tips for how you can get there. First of all, get on the AI-infused testing wave of enthusiasts. Chris is one of them. Chris is an AI enthusiast. Get with people like that and start talking and understanding what it means and how it can help increase business agility, revenue, time to market, and reduce costs. Use the power of analytics and data insights. So you've got a lot of data to leverage that you can run analytics on, including log files, test failures, past tests, test cases, use cases, development, testing metrics. Use that data and run analytics and carve insights to determine what to test next and what to automate next and which automation you should run next based on a change or a new requirement addition or even a hot fix. Utilize the analysis and utilize that data. But prepare for this and do it in small steps. Don't make a lack of technical skills or technology concerns and organizational support from employees a hard stop. Research proves that the use of AI-infused testing and quality management comes with numerous technical and business benefits. Ramp up an initial group of testers to help them understand what AI is about and how it can be used, leveraged, and what exists out there. Then set them free and they can go evangelize and support other testers and coach teams. If you use external partners, reach out to them and find out if they have the right skills to help. And then last, testing takes a village and AI democratizes it for everyone. As an enterprise, you'll need multiple testing personas. And depending on the type of applications or products you build, AI-infused testing tools is the future. And all of the personas can get help from AI-infused testing tools. Developers can use AI-infused testing to improve code quality and mean time to repair. Technical testers can use AI-infused testing to optimize the test strategy. And business testers can use AI-based testing to test business functionality and user experience. Look for tools that can offer AI-infused testing to augment your testers' intelligence collectively. So with that, I want to thank you for taking the time today. We have just about a minute left, so I don't know if we've got any questions queued up. I've included a QR code here on the screen that you can take a snapshot of so that you can get some more information about ValueEdge, our new value stream management platform. And if you have additional questions that we can't get to, feel free to drop them in the chat, or you can email me directly at don.jackson@microfocus.com.